Partial fraction integration can be challenging, right? I know I used to have a really hard time with partial fractions when I was first learning calculus, and integral calculus specifically. It can be hard to figure out what type of partial fraction decomposition to apply. You know, sometimes it may require long division of polynomials, or maybe not. And it can be kind of weird to figure out when to do what type of method. So I wanted to show you an example of partial fraction integration from my weekly live stream that I did recently, where I talked about partial fractions and partial fraction decomposition. If that's a topic that you find kind of tough and you think you could use a little bit of extra practice in that, be sure to stick around to the end of the video, and I'm sure you'll have a much easier time by the end of this video. Well, anyway, that's enough chit chat. Let's go ahead and jump into the example and I'll show you exactly what I'm talking about. We use long division to evaluate the integral, and we're going to integrate r squared over r+4 dr, or with respect to r. So, like it says, obviously this problem tells us we're going to use long division. Well, we can pretty quickly check, like I've kind of been saying throughout this live stream, if we look at a integral that is a fraction like this, where basically everything that we're trying to integrate is within a fraction, where we have a polynomial on the top and a polynomial on the bottom of our fraction. The degree of our numerator, the highest power of our variable on the top, is 2, and the highest power of the variable on the bottom is 1. So the degree of the numerator is greater than or equal to the degree of the denominator. So that is a pretty big hint that we're going to need to do long division. If the degree on the bottom is bigger, you don't need to. If the degree on the top is bigger, or if they're the same, you're going to need to do long division. Obviously, this problem makes it a little more obvious by telling us in the problem to use long division to evaluate the integral, but we could pretty easily figure that out just by looking at the degree of the polynomial on the top and the bottom. So long division, we're going to do r squared divided by r+4. So again, we just put our numerator inside the division sign, our denominator outside, and we're just going to look at our leading terms. So we're just going to start by looking at r squared and r. If we just look at r squared and r, if we did our leading term on the inside divided by our leading term on the outside, what would we get? R squared divided by r would leave us with r. Okay, so then whatever we just wrote up here, we would do r times all this stuff down here. So r times r gives us r squared. R times 4 gives us plus 4r. Then we minus this whole thing, and make sure to put that in parentheses, from whatever is up inside the division sign here. So r squared minus r squared is 0. Minus 4r gives us negative 4r. Okay, so then we're looking at our leading term here. Negative 4r is now our leading term. And let me actually put that in the same color that I did up there. Negative 4r is our leading term. We have this 0 here. That's obviously not doing anything. I'll just get rid of that. So we have negative 4r divided by just our leading term over here. That's all you need to worry about is the leading term. So we're going to do negative 4r divided by r gives us negative 4. So we write negative 4 up here. Then we do this thing that we just wrote here. So negative 4 times all the stuff over here on the left. So negative 4 times r gives us negative 4r. Negative 4 times positive 4 gives us negative 16. Okay. Then again, we subtract all this stuff. Be sure to put it in parentheses from what we had here. Negative 4r minus negative 4r would be the same as negative 4r plus 4r gives us 0. And then minus negative 16 gives us plus 16. So now we just have 16. And now we've gotten to the point where the degree of what we have here, the degree of basically each step along the way, once we get to the point where the degree here is lower than the degree of whatever you have over here on the left, then you can stop. So in this case, we're down to a constant. We can't divide a constant by r. So we're going to be done here. So basically we know that r squared divided by r+4 leaves us with r minus 4 with a remainder of positive 16, a remainder of everything we have at this step, at the point when our degree of this gets less than the degree of this polynomial here. So what does that really mean? Well, what that tells us is we can rewrite this integral we started with as, the integral of r² over r+4 dr. We can rewrite that. If we were to actually divide r² divided by r+4, we would end up with r minus 4, and then we would have a remainder of positive 16. Well, a remainder of positive 16 basically just means we still have plus 16 over r+4. Basically, the 16 was not able to be divided by the r+4, so it's still being divided by r+4. However, what we were able to do is kind of like factor out r minus 4 from it. So now we've basically rewritten this integral as this one here. Well, now looking at this integral, we have something that's much easier to integrate. And in fact, if we look here, we're not even going to need to do partial fractions because we've already got this down into a form that we usually hope to get partial fraction integration problems into, which is we know the integral of some constant divided by our variable plus or minus a constant. I just talked about it back over here. Let me go back down to that formula. It's right here. The integral of some constant over your variable plus or minus some constant can be broken down using this formula. So we can do that exact same thing to integrate what we have over here, which means we can integrate each of these terms, each of these three terms here, kind of looking at these each of these three terms individually. We've got three terms now, which we know how to integrate, that are all just being added or subtracted together. So we can just go ahead and integrate those. The integral of r can be done using the power rule. It's just going to be 1/2 r². We raise our power by 1, so raise our power from 1 to 2, and divide by our new power, or multiply by 1 over that new power. And then let me actually move this over a little bit. I'm not going to have enough room here. Okay, and then minus 4, again, that's basically just power rule. The integral of a constant is just that constant times your variable, so negative 4r. And then using that formula I was just talking about a moment ago, we would just have 16 times the natural log of the absolute value of r+4. And then we would just add in a constant, a plus c. So that's it. I mean, we've just integrated that function. We were able to use long division in order to simplify this function down into a much simpler thing to integrate and just kind of do it term by term. Well, I hope you found that video helpful. If you did, do me a favor and hit that subscribe button and that bell icon down below so that you'll be notified of my live streams and all my new videos. I do a weekly live stream every Monday night at 5 o'clock Pacific. Like I said, that's where this video came from in the first place. And if you're subscribed to my channel, you'll always be updated when I'm going live and if there's ever any changes to the schedule, so you won't miss out. Well, anyway, if you want to keep learning about integrals, I have made lots of other videos about that. Go ahead and click on one of those over there, and I hope to see you on Monday.